Today our group will have a presentation about specific heat capacity. Before we go to the topic, our group consists of Tita, Kaira, Rina, and Johanna Grace. So without any further ado, let's get to the topic.
Specific heat capacity. Specific heat capacity is the amount of energy required to rise the temperature of 1 kilogram of the substance by 1 degree Celsius. The formula are specific heat capacity equals to the change in thermal energy divided by mass times the change in temperature. The change in thermal energy equals to mass times specific heat capacity times the change in temperature. So we will go to the experiment, and tools material that we need are water, mass balance, beaker, small immersion heater, thermometer, ammeter, voltmeter, power supply, stopwatch, a, a light with a couple of holes for the immersion and thermometer.
Work step 1. Add some water to the beaker and record the mass of the water added on mass balance. For this, we're going to be using 227 grams or 0.227 kilograms of water. So 227 grams of water is going to be heated. 2. Connect the immersion heater into a circuit. We have an ammeter to measure the current that's going in series. Then across the terminal of the immersion heater, we have a voltmeter, and we turn on the ammeter and voltmeter. 3. In order to reduce any extra heat loss from the top, we should use small lid that made out of cardboard. There's a couple of holes in it. One of them allows the immersion heater to go through. So that's going through into the liquid as far as possible. So we get the most heating effect. And there's another hole for the thermometer. So just put the thermometer in there. And we are going to let that go to the same temperature as the water.
Next explains.
We are going
Okay.
we are going to record the temperature every minute and leave it switch on for 10 minutes. Basically, what we'll be doing is as soon as we turn on the power supply and the stopwatch. And then we'll record the temperature and the time. It's always a good idea to keep your eyes at the same level as the measurement that you're taking. And don't forget to take a note of the temperature of the water before heated. Because they're going to be all sorts of convection currents inside, we should be stirring the water before we take a reading. Before heated, the temperature of the water is 16 degrees Celsius. After heated for 10 minutes, the temperature is 32 degrees Celsius.
Practical specific heat capacity results. We had mass 0.227 kilogram. We had voltage 9.58 volt, and we had the current 3.39 ampere. And we had the time in seconds and also the temperature. Now, first thing we are going to do is work out the power. The power transferred is equal to the voltage multiplied by the current. So in this case, it's going to be equal to 9.58 multiplied by 3.39. This was equal to 32.5 watts. Now, look at the energy transferred. The energy transferred is equal to power multiplied by the time. So when the time is 0, the energy transferred is 0. When the time is 60 seconds, we are going to calculate 32.5 multiplied by 60, which is equal to 1950 joules. We are just going to continue this for the rest of the table. So now we have got our values and we are going to plot this on coordinate Cartesian field. On x-axis, we have the energy, and on y-axis, we have the temperature. After we plot our data in this coordinate Cartesian field, next we will find out the gradient. So, to work out the gradient, we draw a triangle onto this and put on the points that we have. So, over here we have 3200 on the energy, and the temperature is between 15 and 20, so it's 17.5. This point up here, the energy is 20,000, and the temperature is between 30 and 35, so that's 32.5. Gradient is equal to the change in y divided by the change in x. So it's going to be 32.5 minus 17.5 is equal to 15 divided by the change in x. So it's going to be 20,000 minus 3,200, and it's equal 16,800. So the value of the gradient is 0.000893. The equation says that the energy transferred is equal to the mass times specific heat capacity times delta theta. When we find out the gradient, it was the change in temperature divided by the change in energy. And that means we can use the value of the gradient to this equation. Specific heat capacity is equal to 1 divided by the mass multiplied by the gradient. So the specific heat capacity is equal to 1 divided by the 0.227 times 0.000893. And it's equal to 4,933.9. We can change it into two significance figure, which is 4,900 joule per kilogram degree Celsius. The answer that we got was a bit higher than the real value. The real value for water is about 4,180 joule per kilogram degree Celsius. Why the result is different than the real value? There's a couple reasons for that. First, it might be when we have the heater, it wasn't fully submerged in the water. So, although we were supplying lots of energy, some of the energy wasn't actually heating up the water. Second, we didn't actually insulate the beaker that the water was in. So, maybe in the future, we have a lid which is insulate on top, insulate the size of the beaker, and insulate underneath to reduce any heat loss.
So here we have some question and the answer. Number 1. How much energy will needed to heat 400 grams of copper metal from a temperature of 25 degrees Celsius to a temperature of 70 degrees Celsius? The specific of copper at 25 degrees Celsius is 0.385 joules per gram degree Celsius.